Hi, my name is Sahil Singh, and today I'll be talking to you about the accident that happened at 3 Mile Island in 1979, an event that forever shaped U.S. energy policy and to this day continues to be studied. This presentation focuses on the perceived health impacts of the 1979 3 Mile Island nuclear accident through a data-driven lens, and the purpose is to walk through peer-reviewed research that examined cancer prevalence and exposure levels in populations near the plant. By visualizing that data, we can better understand how the event not only shaped scientific research, but also policy conversations around power plant and overall radiation safety. There are three key objectives. First, I'll provide a brief overview of the incident for historical context. Second, I'll analyze data on cancer risk and patterns following the accident. And third, I'll highlight the continued research that explores these health outcomes decades later. Here we have a quick table of contents. Again, we'll do a brief overview. We'll jump into non-Hodgkin's lymphoma, which quickly became a top priority for scientists and experts alike. We'll talk about the role that proximity played, and we'll delve into a little bit of the more recent research that's being done regarding 3 Mile Island and its lasting effects. So to give a quick summary on what actually happened. So on March 28, 1979, a mechanical failure at Unit 2 of the 3 Mile Island plant triggered a partial meltdown. A stuck valve and operator error prevented proper cooling, and radioactive gases were released to relieve pressure internally. Public concern grew rapidly, understandably, especially after a hydrogen bubble scare and potential hydrogen explosion that prompted the evacuation of pregnant women and young children within 5 miles of the plant. Over the next few months, federal and state agencies launched investigations, and in the following years, scientists began analyzing the health impacts. While radiation exposure was deemed minimal, public fear and scrutiny remained exponentially high. The incident became a turning point in U.S. nuclear policy, which shaped training, regulation, and crisis communication for decades. 3 Mile Island is seldom remembered for the casualties because thankfully there were none, but more importantly for how it exposed the gap between technical safety and regulation and public trust. So in this first pie chart we see here, this slide focuses specifically on cancer incidents in people living within 5 miles of the 3 Mile Island plant, and the study focused on the years of 1982 and 1995. For example, in the scope of this pie chart, among white women, which was one of the cohorts studied, there was most notably 278 cases of breast cancer. It was later found in the study that exposure to higher levels of radiation from the accident at 3 Mile Island did not significantly increase the overall cancer risk in the population. The researchers did emphasize the need for continued follow-up, especially for women who were younger at the time of the accident and may still be at risk for late emerging cancers. In this chart here, we see the standardized incidence ratios, or SIRs, for non-Hodgkin's lymphoma by radiation exposure level from the years 1981 to 1985. So this is based on the data from Hatch et al., which was published in 1990, and they allowed for a 2-year latency period post accident, which happened in 79 and started data collection in 81. As mentioned, a lot of the scientific research was geared towards studying the effects of cancer. Of the most importance at the time was lung cancer, and of the most important cancers overall was non-Hodgkin's lymphoma. In the high exposure group on the right-hand side in quartile 4, we can see that the SRI jumps to 1.48, essentially translating to a 48% higher incidence among national cancer rates. Though this is a statistically significant increase, it is worth noting that non-Hodgkin's lymphoma has increasingly been under the radar as far as not being consistently linked to radiation in other studies, even among atomic bomb survivors. So this result should be interpreted cautiously. In short, this graph suggests a possible association between radiation and lymphoma risk at 3 Mile Island, but doesn't necessarily prove causation. In this next graph here, we see how cancer incidence changed from 1975 to 1985 for people living within 0 to 6 kilometers of the 3 Mile Island plant. And while this isn't a direct measure of radiation exposure, it's rather a proxy for stress, since proximity often correlated with evacuation, fear, and disruption. Residents that lived closest to the plant, especially mothers with young children, which, as discussed earlier, were the only cohort that were asked to evacuate around the time of the hydrogen bubble explosion, did experience long-lasting psychological distress, and researchers essentially wanted to study how that correlated with cancer risk. Upon further analysis, researchers did find a statistically significant increase in cancer incidence for those living closest to the plant, experiencing a 40% higher risk than those further away. This did hold true for both men and women. As far as the more recent research that's being done about Three Mile Island, this map shows the gamma radiation doses within 10 miles of Three Mile Island plant, based on, again, a 2020 study, so just about 5 years ago. We'll see here that each color represents a different dose range, and what stands out is how localized and how uneven the exposure was. So the highest doses correlating to the dark purple color with about 1,600 and above units hit neighborhoods northwest of the plant, while nearby areas had much lower exposure. This matters because early studies often assumed distance equaled exposure, and this map clearly shows that that's not the case, as far as wind direction, terrain, and elevation playing a significant role. It also helps explain why cancer patterns may appear in some census tracts and not others, and why newer research using biodosimetry suggests we may have underestimated actual exposure for the most affected communities. In short, this map is a turning point because it reminds us that environment risk is not just about location, but also about how we measure and how we model exposure. So as far as our key takeaways, so the Three Mile Island accident wasn't just a technical failure, but a public health event with long-term consequences. We now know that radiation exposure wasn't evenly distributed, and official estimates may have been much higher in certain areas. And some studies that even found elevated cancer risks, such as non-Hodgkin's lymphoma, is still currently being disputed. The most consistent theme is that proximity mattered, and people living closer to the plant faced more uncertainty, more fear, and potentially more exposure. Um, as aforementioned, beyond health, the Three Mile Island accident triggered the largest regulatory overhaul in U.S. nuclear history, affecting training, emergency planning, and public communication. Essentially, this isn't just a story about radiation, but how we handle risk, protect communities, and learn from our crises. Thank you so much for your time.